Hello, I hope you can see me, you can hear me. It's the next webinar, again, about object-oriented programming. Let me check sound. Yeah, I think it works. So the subject is, can you say in the chat, somebody, just to confirm that you can see me and you can hear me? Because we had that technical problem one time before. So I have to be 100% sure that it works. Okay, so the subject is subtyping and basically inheritance, because subtyping is the word which not so many programmers are used to, and inheritance is way more popular thing we practice. So I wrote an article about that, and the book section about probably 3 or 4 months ago, where I tried to explain what I think about inheritance in general in object-oriented programming and in Java in particular. And it's not a huge topic. It's not something we need to really talk a lot about. So it's going to be quite short webinar, but that's an important one, I believe, because there's a big confusion here. Mostly because let me have my code in front of you. So most of us, me myself as well, some time ago, like 1 year ago, I believed that inheritance is just one thing, which means which works like extending the qualities and behavior of some class or of some type, and then making it bigger and making it more powerful in another class or type. And then I started to read about that, and I read a number of articles, including the one which is quite popular, written by Alan Holub about 10 years ago, where he said that inheritance as a programming practice has to be avoided as much as possible. And I wanted to understand whether that as much as possible really means sometimes or often or never. So do we really need some places where inheritance is a good practice, and maybe there are no places like that? Maybe this inheritance should be just completely avoided, and we just have to forget this this technique at all. And then I found out that actually there are two different types of inheritance. There are two different types of things which we both call inheritance in most cases. The one thing is, and I will be talking. I'll be speaking really practical. Because again, I read many articles and Wikipedia pages about inheritance, and there are so many names for it: inheritance, subtyping, polymorphism, and many other words which stay around that names. Which is kind of, well, for me, it's kind of difficult to figure out what they all mean. Sometimes I just can't remember what they really mean. So I'll be speaking practically about my Java code, how it works for me, and what actually this subtyping and inheritance, what they are in the practical pieces of Java code. The first one is called subtyping. The second one is called implementation inheritance. And if we think it's one thing, if we confuse them, if you don't understand them, then it's a problem. If we clearly understand what they mean, subtyping and what is implementation inheritance, then I believe the question just disappears. We just immediately will realize that subtyping is a great thing and implementation inheritance is a bad thing. And then it will be just easy and clear to just say that we forget the implementation inheritance because it's bad, and we use subtyping because it's a great thing. So let me explain first what's the difference and why the difference is there. Subtyping is basically the fundamental idea of object-oriented programming, which, in a few words, means that if you're expecting from me a furniture, then a table will work. So that's basically what subtyping is. So if you expect some type from me, if you want to get the furniture, then the subtype of furniture, which is a subset of all the furnitures, which is table, then the table will work and you will accept it from me. You will not accept a thing or an entity or something because you expect specifically the furniture, but you will expect the table, or you will expect a chair. More formally, this is defined as a Liskov substitution principle, but for which has the mathematical explanation of what exactly this subtyping means and how it works. But in the primitive terms, in a simple explanation, it works exactly like that. And subtyping is great because without subtyping, without this, and polymorphism is another name for subtyping. So subtyping and polymorphism, in this particular example, it's exactly the same name. So we want to give an ability to our objects to behave, to have multiple forms. Poly means many, and morph means forms. So we expect that thing which we want, which is furniture, to have multiple forms. So I'm saying, give me the piece of furniture, and I don't really care whether it's going to be a table or it's going to be a chair. So I allow you to give me something which may have multiple forms. It may be a chair, it may be a table. The forms could be different. As long as the thing you give me possesses the qualities and behavior and the qualities and behavior of the furniture I'm expecting. So as long as your table is a furniture, then it's okay for me. That's basically subtyping. And it's great. It's not possible to imagine object-oriented programming without that. You just simply cannot, well, the entire, I think, object paradigm will just disappear if we remove subtyping from our languages, from Java, for example, or from any other language. No matter how strict their typing is and how static or dynamic it is. So, for example, in Ruby, which is a language I write in sometimes, there are no, you don't need to, well, first of all, there are no types there. I mean, there are no interfaces. There are types, but there are no interfaces. There are no protocols. So you can define your class and say that and then you define it's a furniture. But there's no formal way in Ruby to say whether the table actually is a furniture. In Java, you can do that. You can say there's interface called furniture and there's interface called table. And then the interface table extends the furniture, and it's formally the Java will catch you if you break that protocol, if you do something against that. In Ruby, there's no such thing, and in many other languages. But still the subtyping is there. We still need to have an ability to work with an object as if it would, to work with an object without actually paying attention to the form it takes right now. So I have to, in any language, in any object-oriented language, I have to have an ability to work with an object, assuming that it has the qualities I need, without knowing the particular form it has right now. That's subtyping. Implementation inheritance is a different thing. Implementation inheritance, first of all, it's also called subclassing. So if the first name was subtyping or polymorphism, then the second name is implementation inheritance or subclassing. Again, I may be a little bit wrong about that naming thing because I said there are so many names and I tried to put them together, but maybe I'm wrong. But I like how it sounds: subclassing versus subtyping, or subtyping versus implementation inheritance. So implementation inheritance is when we deal with classes, not types. So they're not anymore, there are no interfaces anymore, but classes where we define our properties and attributes and methods, and then we create another class which takes parts of that original class and adds something on top of that, reusing the code we had before. So if subtyping is about our how to say, more or less attitude to the object, then the implementation inheritance is about how we technically treat the pieces of that object. So I'll show you right now the code, the Java code. It will probably become clearer, and then we'll see what we can get from that code. So let me share the screen. Yeah, that one. Okay, so here's the very simple example. let's say I have the interface called metric value, and then I define a class, well, which implements the interface metric. So here we are saying that, yeah, you see how it works. So that's a speed. Well, metric is some metric. We don't know what kind of metric, and then speed is one particular metric, which is also a metric, but it works. Well, it returns, in this case, it returns, let's say, 500 or 50. This is the speed. It's a really primitive implementation of the metric, and then we have that method somewhere which accepts the metric, the type metric. We can provide to that type, we can provide, instead of this metric, we cannot make an instance of the interface metric. We need to make an instance of a class speed or any other class. But here, the method print or the procedure print will not know who exactly, what is the form of that particular metric. So this is like polymorphic parameter. We don't know exactly what's coming in here. All we know is that the method value is there. We just rely on that contract. We just know that what's coming in here, the entity which is coming into this function, will definitely obey the contract which is called metric. This kind of a contract. And that's like I said, it's a great like subtyping, because we can. There are many advantages of that. It's not like so important to discuss them now, but mostly like me as a like practical, I'm thinking what's the advantage? Probably the biggest advantage is that we can decouple the contract from the particular implementation. So I can replace this particular class with something else. This class foo will not know anything about the class speed. All the foo will know is that there's contract and somebody in the future, which we don't know who it's going to be, but in the future somebody will come in and will according to that contract. How it's going to happen, who it's going to be in the future, it's not important. It's not important for this class. This is how will it work. So we will create an instance of foo, and then we'll call print, and then the speed will come in. That's subtyping. It's great. Now the question is about implementation inheritance. Let me show you. Let me show you another piece of code. So we still have this speed. Yeah. So let's say this is the speed. And then let's say we want to, yeah, I made that class a little bit longer. So let's say this is the class speed, which also implements the metric. And I introduced one more, which makes this speed less strict. So it's not going to return 50 all the time. It will make it like randomize it a little bit. So you can see what's happening here. It's not so important, but look, using this formula, we will make that value sometimes 50, sometimes 49, sometimes 51, something like that. And but I'm still in the subtyping zone. And now I will show you the implementation inheritance, which, like I said before, was introduced for the sake of code reuse, I believe. Not in order to decouple something from something, not in order to make, to implement polymorphism, not in order to make the code the design look more modularized or less coupled and more cohesive, whatever. So it was introduced for a different reason, mostly in order to help programmers to do the code reuse without, well, easier, as people who introduced that understood that. So let's say we have the class speed and we have the class cost, for example. So there are two metrics of the same thing, for example, of the car. So we have the speed of that car, the like maximum speed, and we have like a cost of that car. So they both implement metric. They're both like they in the same hierarchy of types, but they obviously have the code. The code is duplicated because this function R&D it stays in both classes, and it's not really nice because we call, well, it's obvious code duplication. So what we do, we say, okay, how about we introduce another class and call it abstract metric. Well, abstract randomized metric, and there are many ways of using implementation inheritance. I'm trying to show the most justified and the most logical way of using implementation inheritance. So, and I'll show you now that even that way is wrong, because there are so many other ways which are completely wrong. It's just no reason to discuss it here. I would do it like that, using implementation inheritance. I would move that method over here, and I would say, yeah, since it's like that, so we still have this. We'll put it like this. It's Java, so it's abstract, and then I would make it protected, and then it will look like that. I extend here. I extend here. Voila. So there is no code duplication. These classes, they look nice. They look like short, and they extend the abstract randomized metric where one method is protected, and the protected means that only the classes which extend me can use it. So it's not public. Nobody from the outside will be able to use it. Only if you extend me, you will be able to reuse the functionality I have for you. To reuse. It looks convenient right now. Well, before discussing whether it's convenient or not, whether it's okay or not, let's just see what it is. This has nothing to do with polymorphism and with subtyping. Even though we can say that the speed is actually an abstract randomized metric. So we can say that like we said before, that the speed is a metric, then now we can say that the speed is an abstract randomized metric. Even though we're saying the same words, and it looks like it's inheritance because we kind of inherit properties of this class, but in reality, there are different kinds of inheritance. In my article on the blog and in the book, I said that actually in English, and I think like I'm not really far from being right here, that in English there are two different meanings of the word inherit. So you can and in Russian as well. So you can inherit qualities of, for example, a child can inherit a shape of a face of his parent, for example, or a child can inherit some, the voice of a father. So this kind of inheritance, when the quality, when the child inherits the quality, but not taking anything from the father, but inherits in the way of let me check the in English how it sounds exactly. Yeah, it says derive genetically from the parent or ancestor. So the key word here is derive. So I take this characteristic or a quality from the parent. This is exactly what's happening here. So this is the quality, the characteristic of a metric. So the metric has a characteristic of which is called I have a value. This is my characteristic. If I am the metric, then my characteristic is that I have a value. And then the speed inherits that characteristic from the metric. So now we say that the speed also has the value. This is what subtyping is about. But here, the inheritance has a different meaning. Again, let me check the Wikipedia what the meaning for the word inherit. And it's different. There are two meanings. The first one is deriving characteristics, but the second one is it sounds like let me check. receive the property at the death of the previous holder. So now we receive the money or property or something when somebody dies. And it's also inheritance. So if the first one was deriving the quality, the second meaning is receiving money or property when somebody dies. So here I think that's exactly what's happening. So this, the ancestor, somebody who had something for us, dies, and this guy, the speed, takes as much as necessary from that object which actually died, or a class or an object, and copies everything. Like this one, maybe there could be something else. It copies all the pieces here and then reuse them. So here we have this kind of inheritance. Even the first case, we were inheriting qualities. Now we don't inherit qualities. We inherit pieces of the code. We basically inherit that piece of code, which is not the quality, but already the piece, already the function, already the the piece of code. It's like a function or method or procedure which we technically take from here and put in there. That's what implementation inheritance is for. So we are, in order to reuse this functionality, we are, philosophically speaking, we're killing that object, this one, this poor abstract randomized metric. We're killing it. We don't need it anymore. And then we just put everything it has in here. So it's about copying. It's not about deriving. It's not about deriving characteristics. It's about copying pieces of code. What's wrong with that technically? Why it's not really a good design? I believe that, well, there are many reasons. People say that these classes are coupled together too much, because if you change something in there, then all the classes which actually inherited that functionality, they will also change. They say that it's difficult to understand the meaning of this, because if you look at this line, you can't really understand where to find it. It doesn't stay here, so you have to go up and up and up, and you don't know how many these ancestors will be there in the hierarchy. So it will take you some time to figure out what's going on. So the design will be kind of messy. It will be difficult to understand. I think that the way we reuse the code here is really not object-oriented. So reusing the code is a good idea in general. We don't want to write this function, this R&D, in both places. We want to reuse it. But reusing it that way is really procedural approach. Because, like I said, we're killing that object. We're not treating this one as a real normal object. It's something half broken. It's some abstract class which is difficult to even understand what it does and what it's supposed to do. So we are not dealing with the proper object here, and that's why that's why we're falling out of the object paradigm and getting back to treating these guys as containers of functions and attributes. Because sometimes we can even put the attribute in here. We can say, I don't know, private, double, thing like that. Then put the number in there. Also may happen. And we can make it not private, but we can make it protected. So both of them will be available for the speed, for this class. But they will be not just available, they will be copied. They will be directly accessible. So this guy will be just a container from which we will take functionality out and put it here. Functionality and data and whatever it is. We'll check just using this extends, this word. We're basically taking this like that. We're just command X, command V. That's what happens. Which means that what's left? Which means that we are not, we're not respecting that object at all. We're not treating it as a solid black box. Instead, we're taking pieces out of it and placing where we want. So this extend keywords allows us to extract what the object contains and place where we want it to place. This is not how a proper object should should look for us. So this protected keyword is no better than the public keyword. It just gives access to, it just allows us to procedurally and brutally take pieces of it and put it wherever we want. What's the alternative? The alternative is that we use composition. Is just you probably heard about that. You can Google and find this composition over inheritance. Just Google by these words, and you will find a lot of suggestions and articles. I'm not saying that composition is the only idea, but even if we just need to stop using extends keyword, and then if we don't have extends, then the question will be, where do I get the code for this? The first option is to put it here and put it, implement it locally. But another option would be even easier. You can create, well, I'm kidding. The utility class would be the last resort, but you can create a kind of utility object, like call it like this. Call it, I don't know, randomized, I don't know, integer, and then implement whatever. Don't implement, just let's make it simple. Randomized integer, and then you have this private, and you have this public, and that's it. And then here you just say new randomized integer, for example, like that. That's really primitive, but this is already better than what we had before. Now we have a proper object-oriented programming, and of course we remove that nonsense. So we put it back. Implements and implements. This is object-oriented programming. Now this object is solid, this randomized integer. Nobody can touch what's inside. Nobody can copy anything from it. Nobody can get that functionality and just place it somewhere. Nobody can extract that functionality, can move that piece of code somewhere else. No, you wanna use that functionality, so make an instance. Make an instance of an object and then call a method, like the normal traditional way of using objects. And my bottom line, I'm finishing. My bottom line is that it will be applicable, that approach, in all cases. So implementation inheritance will not be, you should not use it anywhere. So it's not like the recommendation you've heard in many places where implementation, like inheritance, should be avoided and should be used, like should not be used, or should be used not as much as you use it right now. No, my point is that it's just a wrong idea in object-oriented programming. It was invented as a code reuse technique. Programmers reuse pieces of code in a wrong way. So just don't do it. It was just a mistake to have this extends keywords in Java or in many other languages. Just use objects and reuse the functionality. Do it like that. If you want subtyping, if you want to have the hierarchy of types, then you have interfaces. So put that functionality into interfaces. You define your types in interfaces. You have the hierarchy of interfaces. You can extend interfaces, but it's the same keyword here, but it has a different meaning. So this interface can extend, I don't know, whatever, number. Use interfaces, use the type hierarchy, and of course, make sure that all your classes implement that interfaces. That will be perfect. This is the perfect subtyping technique. But as soon as you start using inheritance for code reuse, that immediately moves you back to procedural programming, because conceptually, philosophically, your objects will not be solid anymore. They will not be objects anymore. They will be just containers for procedures and for data. I mean, I'm talking about objects which you extend, which you inherit with the meaning of taking the property from somebody who is dead. So that's what I think. And now let me get back to the questions. Let's see the questions if you have them. Let me check. Yeah, we have some questions. Subtyping, the first comment is subtyping is one type of polymorphism. Yes, exactly. That's what Wikipedia says. But like I said, there are so many names, so I don't want to be an expert in that naming thing. So yes, subtyping is one type, and polymorphism, there are other types of polymorphisms, but well, just check Wikipedia for the right names. Implementation inheritance means concrete inheritance. Well, again, maybe yet another name. One more. That's the question. How does having or not having public contract affect correctness of is a relationship? That's a good question. So having or not having public contract means that I have an interface. So if I'm a class or an object, then if I have some interface, some protocol, with some contract which I work on, that's one situation. If I don't have any contract or contracts which I work on, it's a different situation. I think that it's super important for all objects to have contracts, because if the object doesn't work by any contract, then there's a big question of how can that object fit into the entire program. So how can we put it in and connect to other objects if it doesn't work by any contracts? If there are no contracts, then basically it's difficult. Well, we can connect it, but that connection will be really well, it will be very concrete, like it was said before. It's a good word. So it will be very concrete and very fixed connection, and it will be unbreakable. It will be untestable. It will be, the coupling will be extremely high, so it will be super difficult to replace one of that things which are connected to each other. So having no contracts, it's like in real life. If you remove contracts from real life, then all our relationship in the world, in the business world, all relationship will be ad hoc. So they will be based on one-time agreements. So we will not know what's going to happen tomorrow, because every time we will have to make specific agreements between people. So let's say you have a company and you want to hire programmers, and then you write up a contract which says what do you expect from that programmers, how much you're going to pay them, how much you expect them to deliver. So you kind of explain how do you want them to protect your secrets and all that things. So you put it on paper, you kind of expect certain way of communication with that programmer. And then you can hire more and more, you can hire 10 people and all of them will work with the same contract. If you don't have that contract, then with each programmer you will have to establish a different kind of relationship. With each person you will have to discuss it again from scratch, explain what is the secret, what means the disclosure of the secret, what means the salary, how much all the details. You will have to put all the details to verbalize them, to discuss them. Will take a lot of time, and you will have concrete connections with each person, concrete connection with each programmer. And every time replacing a programmer will be a nightmare, because you will have to start from scratch from every single person. Contracts, they are invented in order to simplify our life. The same in programming, the same in writing code. So if your object doesn't have any contracts, then it means that everybody who is trying to work with that object will have to make specific relationship with that object. They will need to know what methods to use, what methods are allowed to be called, what kind of results to expect. So they will be really tied to that object really strictly. And so without subtyping, without polymorphism, you will just remove subtyping and polymorphism, because that object will not be able to take a different form. Just like with the programmer. If you made a contract with Jeff, then there's one form of this Jeff, and that's it. Jeff cannot be in any different forms. It's just one specific Jeff, and there's one agreement with that. If you have a contract, then 5 programmers, they're just programmers for you. They just take different forms. It's a Jeff, it's Mary, it's whatever, it's Joseph. They all have different forms. So each particular programmer is just a form of what a programmer is for you as a team leader or whatever. That's what I think it is. How can you tell that something is something if the doesn't have a behavior? Yes, that's probably a question about empty interfaces or something like that. So how can we tell if some object is something if there's no behavior? The behavior is the methods an object has. So if there is no methods, then definitely there is no behavior, and it's a bad object. So it's a wrong design. So an object must have at least one method, and most probably not so many methods. So the behavior has to be explained in the contract. If there are no behavior in the contract, it's a bad design. It's just another question. Yeah, that's a comment. Yeah, when I'm saying solid, I mean just solids. So I'm not talking about solid as a design principle. The capital SOLID. Even though this Liskov substitution principle is one of the letters in this solid thing, is this 5-letter acronym for the design principle. It's really fundamental. I don't think that it's just a principle. It's like a fundamental rule of object-oriented programming. You cannot do object-oriented. You cannot think about objects if you don't have subtyping. But if you have inheritance, implementation inheritance, you are just shooting yourself in the foot. You're just getting back to procedural thinking. And it's just, they stay so close. And even the Wikipedia says that most object, I just found that thing on Wikipedia today. Wikipedia says that object-oriented programming languages, they offer subtype polymorphism using subclassing. So I think they're just wrong. So they're saying, or languages are wrong, or Wikipedia is wrong. So they're saying that for example, Java give us subtyping using subclassing. And that's wrong. Java is not giving us subtyping through subclassing. We have subtyping in Java and we have subclassing. It's just two different things. The Java gives us subtyping through interfaces, and Java gives us subclassing through implementation inheritance. There are two different things which Java gives us. We can use both of them. We can use just one of them. But Wikipedia says that Java gives us subtyping using subclassing. That's kind of wrong. At the same time, Wikipedia explains what's the difference between them. So I disagree with them here. Probably another question. Probably subtyping an interface just for making a class is an anti-pattern. For example, serializable interface. Yeah, that's a question about marker interface, so-called. So that's a design pattern which is called marker interface. The marker interface is an interface with no methods. So that's a good example, serializable. In Java, we have serializable interface, so there are no methods. All you do is that you say that your class implements serializable, and it gives some information to somebody else about that class. That's exactly what annotations are doing in Java. The Java didn't have annotations before. That's why these marker interfaces were introduced in Java 1.2 or whatever, long time ago, 1.0. But then in 1.5, annotations were introduced, and we don't need marker interface anymore. What's wrong with annotations we discussed before in the previous webinar, but that's a different story. But of course, having these marker interfaces, it's a wrong idea because they don't really give any extra behavior. They're not really contracts because there's no behavior. They're just marking. They're just putting a marker on your object, and they could be used only by somebody through reflection or through this instance of operator. The only way for me to understand whether your object has that marker is to say, is your object instance of serializable? That's the only way to get that information. And again, we discussed why it's wrong. So we should not do that. We should not ask objects what kind of contracts they obey, they work for. You shouldn't do that. All you do is that you say that I am expecting that kind of, I'm expecting somebody who is a metric. So I'm expecting a metric, or I'm expecting a furniture. And then somebody shows up, and you're not supposed to say, are you a chair or are you a table? Asking that kind of question would be wrong. That would break the idea of polymorphism, because in polymorphism and subtyping, we're saying that we will accept whoever. We want the furniture. We want a piece of furniture, and then whoever shows up, it's a chair or a table, it doesn't matter for us. We will treat them equally. We needed furniture. We said it already. We gave our statement that we need the furniture, and then somebody shows up, and then we're starting to make a decision, to make a different decision of depending of who actually was delivered to us. It leads to the wrong design, because we're actually, in that case, we can easily say, okay, we don't need furniture, give us whatever, and then we decide what it is. So give us just object, and then whoever shows up, I will make a decision what to do with that. In this case, it's not polymorphism anymore, because that object cannot take any form, because the object cannot decide what form it takes. It kind of transfers that responsibility to us. Now it's our responsibility to decide what to do with you as an object. If you're a table, I'm going to put you in the left room. If you're the chair, I'm going to put you in the kitchen. But it shouldn't be my decision. It should be the decision of the object. The object should come to me and know what to do, how to place itself, to the right room. In that case, we can make many forms. Now we have table and chair, but in the future we can introduce a sofa. But if the decision is made here, then then it will not be enough just to introduce a sofa. It will be necessary to go through all the places on the program and many other libraries and find which code is actually paying attention to whether it's a table or a chair. And everywhere will have to change. And also it's a sofa. Pay attention. It could be sofa. It could be serializable. It could be something else. It could be something else. We will have to go everywhere. And everywhere tell them that now it's a sofa. Now it's a third type. It was 2 types before. Now there's 3 types. This is not what object-oriented was invented for. The polymorphism. Polymorphism means that, or subtyping means that that it will allow me to decouple that decision from you. So it's going to be my decision. I mean, the chair or the sofa or a table. It's going to be the decision made by an object, not by the client of that object. So we just by using these marker interfaces and reflection or instance of operator, we just break the entire object paradigm. We're just getting back to traditional programming where the code is procedural, and then we just transfer the piece of data from one place to another, and then the receiver decides what to do. Transfer the piece of data. The receiver is responsible for the decision what to do with that piece of data. This is procedural design. Object-oriented is about encapsulating the decision inside the object, which goes no matter where, anywhere you place that object, it always knows what to do, because the decision is always belongs to the object. It's always inside. A few more questions. Is it acceptable to use implementation inheritance for implementing the Teamplay design pattern, which is based on the abstract base class? Is it acceptable to use implementation inheritance for Teamplay design pattern? Well, actually, Teamplay design which is based on an abstract base class. This is exactly what I just demonstrated you on the Java example. I think it's wrong, because just like I said, this Teamplay design pattern, it actually, the question with the Teamplay design pattern is, who is that template? So what kind of entity, what kind of living creature is that template? So the template is an abstract class which has something implemented and something is not implemented. So it's kind of a class which is broken, an object which doesn't exist, a thing which cannot be instantiated. So it's like an incomplete piece of something, piece of code actually, and some data attributes, which is designed to be cut in half sometimes and to be killed, and then pieces will be inherited. It's just not object-oriented programming, I believe. The way of thinking like that will lead us to something not really object-oriented. Another question, if you have a cow, horse, and pig, they all are animals, and you want to share the same run behavior, how would you recommend to share that code? If we have, first of all, we have three different classes. They will all implement the interface animal. So we have the animal interface as a type, and they are specific classes, which are cow, horse, and pig. And then we have the behavior run, which we'll definitely put in the animal interface. Run is a method. And then the implementation of that run method will be different in all these three different places. If they have something in common, if that run functionality is the same, or it looks the same, or it shares some pieces, then I will take that pieces out and put it somewhere else, some other different objects. For example, in order to run, all these three animals, they need to, I don't know, they need to give some sound. They need to produce some sound before they start to run. So we need some sound object now. So I will create a new object which is called sound, and it's going to have the method play or whatever, and then each of them will instantiate that object inside the method run and call play. That's what I think I would do. So every time, think about if you want to share some functionality, introduce new classes, introduce new objects, but don't put that functionality in the parent class. It's wrong. This is not how the reuse in OOP, in object-oriented programming, should happen. Another question. I agree with you, but what do you think about, for example, abstract list? The same. I think the same. Abstract list or abstract whatever, that's still the same. So I think it's wrong. Putting functionality in the abstract class and the parent class and the ancestor, it just leads to more confusions in the wrong design. So it's better to put it somewhere else. Just put it. Don't keep it in the parent. Taking pieces of the code from the parent class, simply put, it makes the code messy. It makes the code difficult to understand. But why? Because it's not object-oriented. It's all coming from that. So we're saying why the maintainability suffers, why the code is not readable, why this implementation inheritance is so difficult to understand. Why do I need to click so many these classes up and up, going up in the hierarchy, and why it's happening? Maybe because, I don't know, we inherit too much. Maybe because we design, we don't use the proper design patterns. I believe that all happens because we are just falling out of the object-oriented paradigm. If we follow the object-oriented way of thinking, then everything will become clearer and easier to understand. That's the point. So in this case, in the implementation inheritance, it's just something which is against object-oriented way of thinking, object-oriented strategy. And that's why the abstract list or abstract whatever, doesn't matter what it is. It's just implementation inheritance. Let me ask just two more questions. What do you think about default methods and interfaces introduced with Java 8? That's a good question. So Java 8 introduced default methods which stay in